Platinum resistance temperature collector based on MQTT protocol, usage and debugging. The following will be explained in 5 parts. 1. Hardware introduction and preparation. 2. Software introduction and preparation. 3. Practical operation demonstration. 4. System integration instructions. 5. Troubleshooting guide. Before configuration, let's review the working principle and data flow. The platinum resistance sensor converts temperature changes into resistance signals, which are processed by the device into digital temperature values and then transmitted via Cat1 wireless network to a 4 grams base station. The base station then transmits the data to the MQTT server. After the MQTT client successfully connects to the server, the sensor status can be subscribed to on the MQTT client. 1. Hardware introduction and preparation. Required hardware equipment. Before operation, our company provided hardware includes platinum resistance, temperature collector, 4G antenna, configuration cable, customer prepared items, a computer, platinum resistance sensor, public IP and MQTT server, hardware connection, demonstration. First, connect the 4G antenna. Screw the 4G antenna onto the host's SMA interface. Position it vertically upward. Then connect the platinum resistance sensor. For 4-wire platinum resistance sensors, connect the 2 red leads from the sensor to the red and black terminals on the device respectively. The 2 white leads can be connected to the remaining 2 terminals. For 3-wire type, connect the 2 red leads from the sensor to the red and black terminals on the device. The single white lead should be connected to both remaining terminals. Then connect the wired sensor to the host device. To configure sensor parameters, connect the configuration cable. The red LED will stay on. Plug the USB end into a computer. Turn on the power switch. The green LED will stay lit. Now parameters can be configured. During configuration, the green LED should be steady or blinking. If the green LED turns off during configuration, this indicates the device entered sleep mode. Turn off the power switch and restart after 5 seconds. The green LED will relight. Alternatively, unplug and replug the cable. Close the software serial port. Before unplugging, reselect the serial port. After reconnection, after reinsertion, the green LED will blink. Configuration can continue. 2. Software introduction and preparation. Contact support for configuration software. Open the downloaded configuration software. Find the serial port driver. Find this application and click. Keep clicking next to complete installation. The subsequent steps will not be demonstrated. The serial port can be emulated via the configuration cable. Right-click this PC. Click Manage Device Manager Ports to check if the serial port driver is installed. Setting up the MQTT client. Open the MQTT client. Go to the Settings page. Navigate to the User Information Settings page. Enter the MQTT server's IP and port here. The client ID can be generated automatically by clicking the button. Set the username and password here. After configuration, click OK. Serial port selection. Parameter configuration. Open the platinum resistance temperature configuration software. Select the emulated serial port from the configuration cable. Open the serial port. Next, configure the sensor's parameters. IP settings section. First, select the network. Here, we use the MQTT login method. For demonstration, Thus, select MQTT. Then, set the MQTT server's IP and port. The MQTT server's domain name and port can also be configured, since domain name resolution takes priority. If domain name login is not used, the domain name field must be left blank. MQTT configuration section. The publish topic can be customized. Ensure the format is correct. The subscribe topic must follow topic matching rules. Enter the username and password set earlier. The client ID can be customized. However, ensure each device's client ID is globally unique. Duplicate IDs will cause the older connection to be kicked out. Configuration complete. Sensor will transmit alarm data to configured server. Next is general parameters. Device address uses 4-byte programmable ID as specified in the protocol. Configurable by user. Upload cycle, duration between heartbeat packets to server. For online status confirmation, configurable. Unit, minutes. Longer intervals conserve more power. Receive time is the maximum wait time for server response after connection. Unit, seconds. During this 5-second window, remote configuration of alarm conditions or intervals is possible. See Section 3 of the AC-105 manual for command formats. Server command format in TCP protocol. If no response is detected, the device enters sleep mode. Registration packet can be customized, sent before establishing communication. As an initial handshake, alarm reporting interval is the frequency for repeated alarm transmissions. Unit, minutes. Sensor type should match your hardware. Alarm condition settings. Configure high or low temperature thresholds. Then select the alarm mode according to temperature requirements. Select from 4 intelligent alarm modes to cover various monitoring needs. Temperature compensation corrects measurement deviations. Place sensor in known temperature environment. Record deviation between measured or actual values to determine compensation value. Parameter display section shows version number and SIM card info. This is the APN configuration section. Fill in the APN scenario correctly based on the SIM's carrier and card type. For the specific name, please consult your carrier. Enter the APN username and password as required by the carrier. For IAT cards, these fields are usually left blank, while regular cards may require credentials provided by the carrier. Once filled in, save the configuration to apply. Click Right and reset. Configuration is now complete. 3. Practical operation demonstration. When both the MQTT client and temperature collector are properly configured and connected to the MQTT server, the client can subscribe to the collector's status. Simply enter the publish topic configured in the collector and click subscribe. You will then receive the collector's status including device address, battery level, etc. See Section 5.2 of the manual for protocol details. Here you can see the measured temperature is 27.7 C, which is below the set alarm range, 45 C. Thus the device status shows 0, indicating normal operation. When placing the sensor in hot water, the display shows 67.3 C, very close to the actual temperature. In industrial applications, calibration and temperature compensation can reduce error to 0.1 C. Now the device is in alarm state, with alarm signal showing 1. The above demonstration used our MQTT server. Customers can connect to their own servers, as explained next. 4. System integration explanation. To connect to your own MQTT server, simply enter your server's IP and port in both the temperature collector and MQTT client. Once configured, your MQTT server will receive data from the collector and correctly distribute it to clients. Subscribe to the relevant topics. Note that the collector is A low-power device, acting as a client, not maintaining constant connection. It connects only during communication, then disconnects and enters sleep mode. Data is uploaded in JSON format. See the protocol details in Section 5 Communication Protocol of the AC-105 Manual. V. Troubleshooting Guide. Unstable temperature readings. Check for loose or oxidized terminals causing poor contact. Ensure secure connections. Keep cables away from high interference sources like motors or frequency converters. No data received. Verify server IP or port configuration. Check for SIM card issues, depleted data or weak signal. Contact our support if local 4 grams coverage is unstable. Relocate the device. Serial port not detected. Ensure cable is securely connected. Try different USB ports cables. Check port status in device manager. If abnormal, reinstall serial port drivers. This concludes the complete process for using and debugging the platinum resistance temperature collector via MQTT protocol.